The parametric equations of a curve are x equals 2t cubed minus 1 and y equals 1 minus t squared. We want to find dy dx. To do this, we apply the chain rule. We start with x equals 2t cubed minus 1. We work out dx dt, and of course differentiating with respect to t just gives us 6t squared. We then take y, which is 1 minus t squared, and differentiate again with respect to t. The 1 disappears, and we get minus 2t. The chain we form is that dy dx is equal to dy dt multiplied by dt dx. If we look at this, we can see dt's would cancel if these were fractions, leaving us with dy dx on the right-hand side. Dt dx, it's worth noting, is 1 over dx dt. Dy dt is minus 2t, and dt dx is 1 over 6t squared. The 2 will cancel with the 6, and the t on top with one of those on the bottom. This leaves us with minus 1 over 3t. We now have this expression for dy dx, and we want to find the equation of the tangent to the curve at the point where t is 2. If t is equal to 2, then the gradient of the tangent, which we know is given by dy dx, is minus 1 over 3 times 2, which is minus 1/6. We want to know coordinates when t is 2. If t is 2, x is going to be 2 times 2 cubed, take away 1, which is 16 take 1, which is 15. Y will be equal to 1 take away 2 squared, which is 1 minus 4, which is minus 3. A tangent, we know, is a straight line, so we can start with y equals mx plus c. Y is minus 3. The gradient is minus 1/6. And the x-coordinate is 15. This enables us to work out c. So minus 3 is 15 and 6 will cancel, so this will become minus 5 over 2. And then c is going to be minus 3 plus 5 over 2, which is minus 1/2. So the equation of our tangent is y equals minus 1/6 x, take away 1/2.